Welcome everyone. Today we are going to study the module from electrochemistry, the concept of pH determination using hydrogen electrode. What are the learning outcomes from this module? At the end of this module, we are expected to know about the pH determination using hydrogen electrode. What is pH? Basically, pH is the quantitative measure of the acidity or basicity of aqueous or other liquid solutions. We can find out the pH of various solutions. We have pH scale ranging from 0 to 14, which shows us 0 to 6, which is acidic, 7, which is neutral, and 8 to 14, which is alkaline in nature. To start with, pH of the solution is defined as the hydrogen ion activity expressed in terms of reciprocal logarithm to the base 10. This statement can be written in the form of an equation, that is, pH is equal to log of 10 into 1 divided by the activity of H plus ion. Now, log of 10 into 1 divided by the activity of H plus ion can be also written as minus log of 10 into activity of H plus ion. Here are some few important points. First, the determination of pH solution is one of the most extensive applications of EMF measurement. Second, in all the determinations of pH of solutions, first a cell is set up in such a way that one of the electrodes is reversible H plus ion and platinum electrode is dipped in that solution. Third, the other electrode is generally a reference electrode. Now, what is a reference electrode? A reference electrode is the one whose potential is already known, and it is used to find the potential of unknown solutions. Fourth, the liquid junction potential is eliminated by means of a suitable salt ring, which is an inverted U-shaped tube. Fifth, the EMF of such a cell is then measured by using potentiometer. Here is the setup of the cell. Let us consider the following cell combination. We have two cells. First, platinum, which is at the anode in contact with the hydrogen gas, which is in contact with the H plus ion. This cell is in contact with the salt bridge, with in contact with the H plus ion, which is in contact with the hydrogen gas, and platinum electrode, which is at the cathode. Now, here the hydrogen gas which is used in this cell is of 1 atmospheric pressure. Now, the EMF of the cell is given by EW is equal to RT divided by NF into Ln into activity of hydrogen ions of the solution 2 divided by the activity of H plus ions of solution 1, which in turn gives us the equation as 2.303 divided by NF log of 10 into activity of H plus ion of solution 2 divided by the activity of H plus ion of solution 1. Now, what are all these symbols? R, T, N and F? They are the constants. That is, R is the gas constant which has a value of 8.314. T is the temperature at 273 Kelvin. F is the Faraday's constant, which has a value of 96,500, and N is the number of ions, which has a value of 1. Now, at 25 degrees Celsius and N is equal to 1, the above equation changes to EW is equal to 0.0591 into log of 10 into activity of H plus ions of the solution 2 divided by the activity of H plus ions of the solution 1. Now, activity of H plus ions of solution 2 is known to be 1 and activity of H plus ions of solution 1 is unknown. Therefore, EW is equal to 0.0591 into log of 10 into 1 divided by the activity of H plus ions of solution 1. But here we know that log of 10 into 1 divided by its activity of H plus ions of solution 1 is equal to pH. Therefore, when we substitute in the above equation, we get EW is equal to 0.0591 into the pH. The pH value we have got as log of 10 into 1 divided by the activity of H plus ions of solution 1. This value is equal to pH. Hence, we have substituted in this equation. Thus, the pH of the solution is given by the following formula, that is pH is equal to EW is equal divided by 0.0591. Hence, we have got to the final formula, and this formula is used to find the pH of the solution using hydrogen electrode. Here are few numericals to be answered. First, the electrode potential of a standard hydrogen electrode is assigned a value of dash. We have the options as A 0 volt, B 1 volt, C 100 volt and D 10 volt. The solution for this question is standard hydrogen electrode is a redox electrode which forms the basis of oxidation reduction potential. The standard electrode potential value of hydrogen is declared to be 0. Hence, the correct option is A, that is 0 volt. In hydrogen electrode, the electrode is placed in a solution of dash. We have the options as A 0.5 molar HCl, B 1 molar HCl, C 2 molar HCl and D as 3 molar HCl. The solution for this question is, in hydrogen electrode, the electrode is placed in a solution of 1 molar HCl. H2 gas at 1 atmospheric pressure is passed to the side arm in such a way that the platinum is half immersed in HCl. Hence, the correct option is B, that is 1 molar HCl. A half cell reaction is the one which the options are A. Involves only half a mole of electrolyte, B. Goes only halfway to completion, C. Takes place at one electrode and D. Consumes half a unit of electricity. The solution for this question is, in an electrochemical cell, a redox reaction occurs. Oxidation occurs at one electrode and reduction occurs at another electrode. The reaction occurs at each electrode and hence it is known as half cell reaction. Hence, the correct option is C, that is, it takes place at one electrode. The hydrogen ion concentration of a fruit juice is 3.3 into 10 raised to minus 2 molar. What is the pH of the juice? Is it basic or acid? The solution for this question is, the definition of pH is given as pH is equal to minus log into the molar concentration of H+. We are given the molar concentration of H+ as 3.3 into 10 raised to minus 2. On substituting into the definition of pH, we get pH is equal to minus log into 3.3 into 10 raised to minus 2. Hence, on further simplifying, we get the answer as 1.48. Since the pH is less than 7, the solution is said to be acid. The equilibrium constant for a cell reaction is 4 into 10 raised to 6. Find the E naught of the cell for the reaction. The options are A 0.63 volts, B 0.49 volts, C 1.23 volts and D 3.24 volts. Given Kc is equal to 4 into 10 raised to 16. E naught of cell is equal to 0.059 divided by 2 log of 10 into Kc. Therefore, E naught of cell is equal to 0.059 divided by 2 into log of 10 to 4 into 10 raised to 16. On simplifying, we get the answer as 0.49 volts. Hence, the correct option is B, that is 0.49 volts. Here are a few references which I have been used for this module. That is Dr. R.N. Madan, Chemistry for Degree Students, BSc Chemistry, Eastern Publication, and Gurdeep Raj, Advanced Physical Chemistry, Choir Publication. Thank you for watching.